Okay, today we're going to take a brief set of notes about some formulas that we use in geometry. Okay, so the first set of formulas we're going to use here are perimeter type formulas. They're basically, if I have an object, it's the distance along the edge of that object. The first one we get is for a rectangle. So if I have a rectangle, I tend to visualize it as having two dimensions, a length and a width. And the perimeter of a rectangle is going to be 2 times its length plus 2 times its width. Or if you want to factor out the 2, you can say it's 2 times the length plus the width. Pretty straightforward. If I have a square, which is a special type of rectangle, where all of the sides are congruent, I only need to know the length of one side. So the perimeter there is 4 times the side of the square. Triangle. Well, here you can have literally something that has 3 different side lengths, A, B, and C. And the perimeter of that is just add up the sides, so that's pretty straightforward. It's almost like, hey, that's the perimeter of anything. And then we get a little special case down here with a circle. Now in a circle we don't call it a perimeter, we call it a circumference. And here you can either imagine the circle having a diameter d or a radius r, right? And the circumference will either be equal to 2 pi r, or another way of saying this is it's pi d. Now what's interesting about this is this mathematical number pi is actually defined as the ratio of the circumference to the diameter of a circle, and it's a constant. And as we've seen before somewhere, it's approximately 3.14 or approximately 22 over 7, but it is an irrational transcendental number that can't be written as a decimal or a fraction easily. So those are a set of formulas that we need for perimeter. Okay, so likewise we need a set of formulas that are useful for area. So this is the amount of space an object takes up. So again, we'll start with a rectangle. And again, we're using the 2 dimensions, length and width. And the area here is just going to be the length times the width. If I have a square, again, the square only has 1 dimension. So we can just say that that is, area is s squared. Aha! So this word squared has something to do with the fact that it is a square. Later on we'll see the relationship between volume, cubes, and cubed. Okay, so let's say we have a triangle. Now the triangle is a little bit tricky because I have 2 dimensions I'm going to use here. I can use its base and what's called its altitude. So the altitude is that height from the bottom to the top. Now note that altitude is not always inside the triangle. So like the area of this triangle is going to be determined by using this altitude, which is on the outside. And hopefully at some point you've seen that the area is 1/2 the base of the triangle times its height. Okay, and finally, area of a circle is another formula that we're going to need to know. And if I have a circle, this time I'm only caring about the length of its radius, and the area happens to be pi r squared. And later in this course, as we take a deeper dive into area, we'll prove some of these things, like the triangle one and the circle one. So I'm just going to advertise now that that's coming, right? So let's summarize a little here. Okay, so let's try to summarize a bit. We had perimeter, And we had area. And we had rectangles, squares, triangles, and circles. The rectangle perimeter formula was 2L plus 2W, or 2L plus W. The perimeter of the square is 4 times its side. The perimeter of the triangle, you just add up the sides. And the perimeter of the circle is either 2 pi r or pi d. And area for a rectangle is length times width. Area for a square is side squared. The area for the triangle is half base times height. And the area for a circle is pi r squared. Okay, so that's formulas that you're going to need to know over the days to come.